probability line goes from 0 to 1, and if you're at a 1, then it's certain, okay? If you're at a 0, it is impossible. Impossible, okay? And so if you hit between those two, it's likely, but if your number's between 0 and 0.5, it's unlikely, okay? And if you think about it from a percentage standpoint, because these are decimals, right here, you're at a 50% chance, but at the 1, you're at a 100% chance, which is why that's certain. Okay, does that make sense? So what do you think the likelihood is that we have a skills quiz tomorrow on simple probability is going to be? 0.5 could go either way. All right, we'll go with that one. I would be tending more towards the higher end of the scale, but you know, I'll go with that. All right, so sample space. All right, the sample space is the set of all possible outcomes. Okay, so if I'm looking at the probability of rolling a 6-sided number cube, or die, whatever you want to call it, okay, what are all my options? What are all my outcomes? I could roll a 1, I could roll a 2. Those are my sample space. I could roll the 1, the 2, the 3, a 4, a 5, or a 6. Probability is the likelihood an event will occur okay, and it basically is the possible, it's a ratio, so it's the possible outcomes over your total outcomes. Okay, I'm going to box that in because that's my formula for probability. And since it's basically a fraction, you can write it as a fraction. But how else can we write fractions? We can divide it and then get a decimal, right? Or turn it into your percent. So when Jim Ganal says there's a 82% chance that once again it's going to snow today, that means that he had 82 out of 100 based on whatever data they pull through and stuff, okay? The symbol is P for probability, and then it's whatever the event. Okay, so I'm just using A as a symbol for it. So that's like your events of what you're looking for. Good so far? Is this coming back to you? Good. All right, so if I want the probability of rolling a 2 on a 6-number die, how many possible outcomes do I have? I have one outcome. which is getting a 2 out of 6 total possible, because I have the sample set of the 1, 2. So I have 1 over 6, or 0.167, or 16.7%. Good? All right, rolling an even number on a 6-sided die. Well, how many even numbers do I have? I have 2, I have 4, and I have 6. So I'm going to have 3 out of 6 chances, which is 1/2. So I have a 50% chance. All right, flipping a fair coin. What's it mean to be a fair coin? Anybody know? It means it's not weighted. You know, when you're at the fair, and they have like the darts and the balloons and stuff like that, they weight them so that you can line it up perfectly. But since they're weighted funky, they're not gonna, the chances of you hitting the balloons and stuff like that are not as good, because that way they make more money. Coins and dice can be weighted, excuse me, I'm choking on the orange, can be weighted a certain way so that they always end up on a die. Kind of thing. Anybody watch, what is it, Ocean's 11 and, you know, all those? And the one where they weighted all the die so that when he, I think it was like a lighter, he flicked the lighter, the die would just automatically go over to Snake Eyes so that they won. That's how they do it. So if it's saying a fair coin, that means it's not weighted. It's fair. It's honest, okay? It's just a logistic of, because you could always say, well, the probability is going to change if it's weighted. So they always specify if it's a fair coin. So, landing on heads. How many choices do I have? 2, because it's either going to be heads or tails, so that's my total possible. And what's the choice landing on heads? Just 1. So that's going to give me a 50%. All right, selecting a green marble from a bag containing 3 red, 4 green, and 5 blue. Well, how many green marbles do I have? And how many total possible marbles do I have? Which is going to give me 1/3. Which is 33%. Good? All right, so you can do Venn diagrams to help find to help clarify how many you have. So I have a spinner. Has sections numbered 1 through 8. Event A is spinning an odd number. Event B is a number greater than 2. Okay, so let's think about all my numbers. 1 is going to be odd, but it's not greater than 2, so it's just an A. Would you agree with that? Okay. What about 2? Is that odd? Well, middle's got to be in both. Is it gonna? Is it an odd? No, so I can't go there. Is it greater than 2? No, so it just comes out because it's not in either one of them. Okay, what about 3? Is it odd? Is it greater than 2? Then it goes to both. 4's even, but it's greater than 2, so it's going in B. 5's odd and greater, so it's together. 6 is going to be just in B. 7's going to be in both. And then 8's going to be in okay. All right, thinking about that, you can show your probabilities for each of these as well and show them the Venn diagram as a. So what's the probability of A? It would have been 1 out of 8, absolutely. What's my probability of B? 1, 2, 3 are in B. And there's 8 total. The probability that I'm going to have the intersection is the middle. So that would be 3, 5, 7. So that would be 3 out of 8. What's the probability of both A and B? How many numbers do I have altogether? I have 3 in this one, 3 in that one, 1 in that one. So that's going to be a 7/8. And then the complement, what's not included in both, I have what? 1, because I had that 2. So that's going to be a 1/8. Good so far? Okay, anybody remember what a tree diagram is? It looks like a tree because each one grows. You start here and then you branch out. I want a ham and I have a choice between Swiss and cheddar. And then I have a choice between white or wheat. Remember these? Yeah? Okay. All right, so let's do a tree diagram, but this one about all the different outfits we could do. All right? So I have a tan and a red shirt. I have shorts that are gray or khaki. So with my tan, I could wear gray or I could wear khaki. And with the red, I could wear gray or I could wear khaki. And then I have 3 pairs of socks. I have black, I have navy, and I have white. So with my tan shirt and my gray shorts, I could wear black, navy, or white. And the same with the tan and khaki, I could wear black, navy, or white. This is why I don't like tree diagrams. I always run into each other. I never space them out far enough. So, repeating again, black, navy, and white, and black, navy, white. However, tree diagrams are super helpful when you're finding your probability. So, if each outfit has equal probability of being chosen, I'm looking for the probability he's going to find the red t-shirt, so here, the khaki shorts here, and the white socks here. So it would be that outcome. How many outcomes do I have that we can choose? Just the one, right? So how many total possible outcomes do I have? Because 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
Do you know where Miss Schmock is?
Not here today, I don't think.
Oh, she's not here today.
I don't think so. But no, I never know her. I never see her.
Okay.
Sorry. All right, what's the probability I'm going to hit a tan t-shirt and gray shorts? So I have a tan t-shirt, gray shorts. How many possibilities do I have? 1, 2, 3 total outcomes, because I could have these two wearing black, navy, or white shorts. So I have 3 possible outcomes. Are you with me on that? And then I still have 12, so that gives me a 1/4. Okay, and what's the probability he's going to select gray shorts? Well, I have a gray short choice here. Oops, it'd help if you could see. And I have a gray short choice there. So that gives me 2. Agreed? And a 12, so that would be a 1/6. Good so far? Nice. All right, one more. This is my, How did you get 6? Good. I'm glad you caught that, because yes, I wanted to see if anybody would catch that. Did anybody hear what he said? He said it really was going to be 6 choices. I have gray shorts here, which means I have choice 2, 3. I have gray shorts here, so choice 4, 5, and 6. Does that make sense? So that means I really have 6 out of 12 or 1/2. Did I lose you on that? When you're counting the amount of choices, always go to your end, the very end of it. Okay? All right, let's do charts. Okay, the tables actually really does make it very easy when you're doing like unions and intersections. So, it's got the results of a survey of students in high school that asked if they prefer rock or rap music. All right? So, I have 15 who like rock, and I have 35 who like rap. So, of all the 9th graders, I need that total because that's going to give me my total possible outcomes, right? All right, so 15 and 35 is going to give me 50. They all equal 50. And so that gives me 200 total students. And rock, 98 like rock, whereas 102 like rap. Okay, so what's the chance that a student chosen at random is a 9th grade student and prefers rock music. So I have 9th grade, I have rock music, so that would be 15. What's my total? My total is going to be out of everybody. And so that would be out of 200, which is 7.5%. All right, what's the chance that a student chosen is a 10th grade student who likes rap music? What do you think? Well, what's my possible outcomes? 10th grade rap gives me 24. What are all my total possible? 200. And because I already divided it out, okay? What's the probability that a randomly selected student is going to prefer rock music? Because it's total possible. What's my total possible? 98. And what's my total of all the samples? The 200. Perfect. Which gives me 49%. So what's 14 going to be? What's the probability an 11th grade student chosen at random prefers rap music? What'd you say? Where'd you get the 100? That's a good thought, except, yeah, Hunter? It would be 25 over 50 because we have 25 who like rap, but the key here is that we're looking at only the 11th grade students, and I have 50 11th graders.
Why would you have the same with the 10th graders?
Because the chance that a student chosen at random is a 10th grader who prefers rap. When you're just choosing any of them that like, but this time we're looking at what's the probability that's the 11th grade person. Does that make sense? Okay, so what's the chance that a randomly selected 12th grade student, so what's my sample space that I'm looking at? Am I looking at the whole population of the high school? No, I'm looking at just the 12th graders, and I had 50 of those, and 32 liked rock, so that gives me a 64% chance. Okay, good. All right, practice problems for simple probability. Is you're going to do your tree diagram. Don't forget all the information for the deck of cards that I gave you yesterday. All right. This is the sandwich tree diagram. And then you're going to fill it. We even did the totals for you. So you're just going to find your probabilities. All right. Easy peasy. Lemon squeezy. Love it.